Welcome back. So today now we are sort of into a really interesting topic called Simpson's paradox. We will explore it by an example, but the interesting and beautiful aspect of this small lecture is that we will see it through the lens of linear algebra. Let's see how. So let's see this problem. Let's come back to this problem. A kidney study is done and there are two drugs A and B. So there are two types of stones, small stones and large stones, on which the two treatments are being applied. And the treatment A is both better than treatment, like better than in treatment B in both the corresponding aspects of small stones and large stones. See the data: 93% of treatment A, 93% of treatment A in small stones is more than 87% of B, and 73% of treatment B A is better than 69% of treatment B. Okay, the corresponding aspects of success. The actual question is that which treatment is better. So the natural intuitive idea is that A must be better, right? But if you calculate in terms of total number of success, you will see that A will give rise to 273 by 350, and B will give rise to 289 by 350. So B is winning here, okay? B is much more successful. B is a better treatment. So where is the illusion coming from? What is actually hiding behind the scenes? Okay, we will explore that now, and we will explore that through the lens of linear algebra. Let's move ahead. So what I will do with linear algebra is I will make sense of this percentage, what really it means by the percentage, okay, and what really we are trying to do. We will see how this percent A by B is related in terms of linear algebra. So A by B can be easily represented as in a graph of a vector B, A comma, not A comma B, but B comma A is का slope, right? This vector का slope, right? Slope is B by A by B, right? Natural. So it's telling that there are two vectors. So one slope is better than another vector, like another vector is better than another vector in terms of slope. That means A is greater than B, say. That means here, so let's say B A is greater than B means this Q by P, or other P by Q is more than A by B. That's what we mean over here. Okay, that means this slope is greater than this slope. That means this percentage is greater than this percentage. Why? Because number of successes is this, and by total. Okay, so P is the number of success, that is number of success by this is the total. Okay, then this is the vector corresponding success vector. The slope means the percentage of success, the probability of success, the percentage of success, okay, the fraction of success. So essentially what we are trying to do is that we are trying to sort of understand this. So there are four blocks over here: A by B, P by Q, C by D, and Q by R by S. So here we're trying to see that A by B is greater than P by Q, and C by D is greater than R by S. That means these two are here, but when you combine this to get A plus C by B plus the total, and P plus R by Q plus S, this is becoming better. That means, but this also implies that P plus R by Q plus S is greater than A plus C by B plus D. That is what the idea is. This is the A, this is the B, okay. A and B are individually large stone, small stone. A and B are individually working better. A is individually working better in each of these groups, but together B is working better. Okay, this is the mathematics behind it. And how will we represent these numbers? We represent these numbers by this. Now, by these vectors, the slope of the vectors. Now, the question is that how can we represent P plus R by Q plus S in this vector format? Let's try to understand it. So P plus R, so let's this is Q comma P, okay, with slope P by Q, and this is S comma R with slope R by S. So if you just add these two vectors, then what you get? You get Q plus S comma P plus R, and this vector ka slope is what? This vector ka slope is P plus R by Q plus S, right? This is the idea we're going to use. This is the idea we're going to use, that where there are two vectors, this vector, so this is the idea. So essentially you can sort of understand it that this is slope of v1, this is slope of v2, this, or let's say not v1, the slope of w1, this is a slope of v2, this is slope of w2. Okay, if we add it up, we'll get slope of v1 plus v2, and here we'll get slope of w1 plus w2. Let me erase this stuff over here. So what it means over here, that slope of v1 plus v2, that is slope of v1 is greater than slope of w1, and slope of v2 is greater than slope of w2. But slope of w1 plus w2 is greater than slope of v1 plus v2. We'll construct such an example by diagrams. Okay, slope of v1 is greater than slope of v2, that is this is greater than this, and slope of v2 is greater than slope of w2, that is this is greater than this. But here combined case, this w1 plus w2 is actually better than v1 plus v2. That's the idea, and I will show an example of this. Okay, let's go to the example. Yes, this is the idea. So observe this very carefully. Now it's very simple. So observe that here's L1 is greater than, so V2 is greater than L2. Okay. So I think I need to, yes, annotate it here. So observe that B2 is greater than L2, and here B1 is greater than L1. This is a B1, this is L1. Okay, but combined L1 is greater than L1 plus L2 is greater than B1 plus B2. This is a diagram. It's really simple. So here is the how we did it. B1 increase to B2, B1 plus B2 we get this, L1 plus L2 we get this. Simple stuff. So essentially this is a linear algebraic view of this. Okay, how essentially they can combine together, one can produce a larger amount of impact. Okay, what is the data perspective, statistical perspective of it? We will see it now, and observe also that this L1 is actually giving more weight. This L2 is giving more weight, okay, and this B1 is giving more weight rather than B2. So rather, if we compare between L2 and B1, L2 is better than B1. Okay, that is the idea. That is the data perspective of it. Okay, let's see what is the data perspective of it. This is the data perspective of it. Let me clear all my drawings here. So observe that A large is over here, B small is over here. Okay, so this is X is number of success by this is number of failure, the total, yes, I guess, yes. So observe that B small is actually better over here in terms of A large. Okay, and B small has much number of trials too. Okay, A large has much number of trials. So essentially, when we are adding all the trials, B large is very small as compared to B small. B large is very small compared to B small. Okay, this is negligible, and A small is very small respect to A large. Okay, so essentially what we are doing is essentially comparing B small and A large together. Okay, and essentially if we compare B small and A large, and if we select B small as representative of B and A large as representative of A, then observe that B is working better than A. But individually, since their sort of like their effect is less, since the number is less, the total number of cases, it's not really good. Okay, so that's the essential idea. Now there's another view of Simpson's paradox, for the idea of correlation and stuff like that. Let that be another topic for another video. And I hope you understood the concept between linear algebra and Simpson's paradox together. The statistical part, let's meet together in the next video with the statistical part. Okay, see you in the next video. Stay tuned, stay blessed. Bye bye.